Hey guys, this is Ulrich from Nostalgic Mathematics. Today I'm going to show you in this video how to compute these challenging limits. If you are new here, do not forget to subscribe. We will compute these limits. Again, we will use this famous result. So we call this function fx. In order to use this result, we should get rid of all the cosine in the expression of f. We start by the first cosine here in red. We know that cosine t is also sine pi over 2 plus t. So this is going to be sine of pi over 2 plus pi over 2 cosine x. But we can factor as here. Next, we get rid of this cosine. We know also that cosine t is 1 minus 2 times sine square t over 2. So cosine x here is 1 minus 2 sine square x over 2. We can just rewrite a little bit like here. Because 2 over 2 is 1, so fx we write as follow. Again, fx we write as follow because this is pi minus pi sine square x over 2. We also know again that sine pi minus t is sine t. So fx is also equal to this one. Now we only have sine in the expression of f. So we'll try to have this kind of pattern, sine z over z. So with this, we pick up z to be pi sine square x over 2. So we add this z at the denominator, and it is compensated by this term. Now, for sine square sine x, we will use sine x, but since sine is square here, we also square sine x like here, and we compensate by using sine square here at this denominator. Next, we further simplify this third term because sine t is 2 times sine t over 2 cosine t over 2. So sine t over 2 over sine t is 1 over 2 cosine t over 2. So this further simplifies as pi over 2 times cosine x over 2, the whole thing square. That's why we have 4 cosine square x over 2. Now we compute the limit of every term here. The limit of the first term is 1. We just have to use zx to be pi sine square x over 2. This is going to 0 when x is going to 0. So that's right. The second one is 1 as well. We use here zx is sine x because this is going to 0 again. And the third term is straightforward. Since this function is continuous around 0, the limit is going to be pi over 4 times cosine 0. But cosine 0 is 1, so this is pi over 4. I mean cosine squared, but it is still pi over 4. And therefore, the limit of fx is 1 here, multiplied by 1 square, multiplied by pi over 4. So the limit we were looking for is pi over 4, and we're done. Thank you for your attention. Again, do not forget to subscribe, like, share, and post your comments. Bye.